So in the second iteration, you see vehicles are all going through the lower part. So minimize it. So it's done. And if you click this parking lot button, you will be able to use edit auto routing selection function. And here you will be able to see from zone 1 to zone 2, the two paths that I just discovered. So these are two paths from zone 1 to zone 2. And you can see the cost, you can see the distance. See that? And if you click this alternative path search, you can specify a function called penalization of the shortest path. So if you click this, the shortest path will have less weight. So it's beneficial for route search. And I just run it twice already. I have already run it twice. And in the third time I'm running it, you will see that there is no new path discovered. So the vehicles are going to use both of them. So both the upper part and the lower part. And that's how VSIM is using the learning process to do dynamic traffic assignment. In VSIM, you are allowed to run the model multiple times. And you can specify two parameters I will describe later. And you can store the results to so-called evaluation files. You can specify that. For the volume increment, this parameter, it means for every iteration, the demand is increased by this value. So the first time, for example, if it's 10%, then in the first iteration, only 10% of the demand will be assigned. And the second iteration will be 20%. And third iteration will be 30%. I think it's already finished, this example. So if I go to edit auto route selection, okay, if you want to see this menu, make sure you selected this parking lot button, otherwise you won't be able to use it. Edit auto routing selection from zone 1 to zone 2. You see these costs, they are different from the last run. The cost from zone 1 to zone 2. Okay, so their cost have been updated for every iteration. And they finally become very similar to each other. So that's what we call user equilibrium. That's the way that VSIM employs to find the user equilibrium. You will see that 83 vehicles are using the first route, and 81 is using the second one. And that's the result of the discrete short modeling. If you want to run the model multiple times, you go to simulation and multi-run. Here you can specify the volume increment and the number of runs and the random seed. So if you specify 10, then the model will be running 10 times, unless you have a convergence criteria. So I already talked about how to view the routes and how to search for alternative paths. I want to talk about this cost file and path file. In VSIM, if you run the model several times, for example, in this case, originally I only had two files, IMP file, which is the VSIM model, I originally have this IMP file. This is the VSIM model. and I have this demand.fma, it's just a body matrix. But when you are running it, you are going to get two new files, one called BEW, the other one is called WEG. WEG file stores the path of the cost. The WEG file is like this, and the BEW file is like that. They are all ASCII files, and you are not required to understand what are contained in them. But just remember that the cost file is BEW and the path file is WEG. So in every iteration, these files will be updated. These files will be updated, and in this dialog, you can click these archive files. So in every iteration, the files will be backed up. So for example, here, I already run it 3 times, and that's why I have 3 sets of BEW and WEG files. And there are 2 things I want to talk about in this. The first thing, the next thing is called dynamic routing decisions. And in the first lecture about VSIM, I talked about these static routing decisions that you use for turn left turn, right turn movements. But you can use dynamic routing decisions, which is very similar to these dynamic traffic assignment, but they are used when the vehicles, they are not used in the beginning of the simulation. When the vehicles approach these dynamic routing decision points, they are going to select their routes according to some criteria. And the last interesting thing is to convert routes to static routing decisions. That's very interesting. So we use dynamic traffic assignment, and we found 2 routes, the upper one and the lower one. If we use this create static routing, then I just created 2 routes, static routes, like what we mentioned in the first lecture of VSIM. See, these 2 decisions, 2 routes, are converted from the result of dynamic traffic assignment. So you can, in some cases, you may want to first use the dynamic traffic assignment to find some possible routes, and then adjust them by converting them to the static routes. Okay, so I just finished the part of DTA in VSIM. Do you have any question about that? If no, I want to briefly introduce MSUM DTA. In MSUM DTA, the first difference is they are quite similar. They are somehow similar. But the first difference is in MSUM is using the k-shortest path. It's not using iterative simulation. They try to solve all the shortest paths in one shot. And they use an algorithm called k-shortest path. As we all know, k-shortest path is a very difficult problem. So, and they are still using Dextron. But the way they are doing this is by incremental loading. So they have a static assignment module, and they are in MSUM, the volumes are incrementally loaded by the static assignment model. So the cost of each link will be different after each loading. And after each loading, MSUM is using the Dextron algorithm to find a new shortest path. And that's the way that MSUM can find several k-shortest paths. And in MSUM, you are also defining time interval, and vehicles are rerouted for each time interval. In MSUM, you are going to get more route choice models, including the logic model and other models. And you can use your own user-defined models. You just need to write some scripts. So you have more options of route choice models. Other than that, they are quite similar. And you already know how to do it, because in the first lecture, you already specified the OD matrices. So you already know how to do it. The next one is called cosine DTA. or netsim DTA. CoSIM has two parts, netsim and FreeSIM. FreeSIM is for freeways, and it's very different from what we are talking about today. So I just ignore it today. NetSIM is about urban network, and in CoSIM or NetSIM is using an iterative procedure. So CoSIM is also dividing the whole simulation into several iterations. Oh no, it's repeating. It's still an iterative procedure. So it's very close to vSIM. So CoSIM is also running the model several times, several iterations, and the network cost is evaluated. And they perform a line search for adjusted flows, to adjust flows, to minimize the network cost. So their purpose is not UE, but SO, minimizing the network cost. And they are using two functions as the VDF, volume delay function. They use either BPR function of Federal Highway Administration, or another function, a set of functions called Davison's functions. The next thing is called parametric DTA. Parametric DTA is a bit different in that it divides the drivers into two types: familiar drivers and unfamiliar drivers. Familiar drivers are rerouted at each interval, but unfamiliar drivers, some like new drivers, they only use the primary route or the shortest path, so they won't change. This is something different. So I guess this part is better than vSIM. It's more realistic, but we cannot justify that. But I just want to show they are different, and it's using a simpler approach called a stochastic all-or-nothing approach. In parametrics, the general cost is defined by travel time, travel distance, and toll price. And this is simpler than vSIM. And the way they are going to find path is still using all or nothing, or the shortest path. But a random error factor, if you want, can be added to the total perceived cost of each path. So you find the shortest path by the cost of each link, and this cost can be added by a random error factor. So this is called a perturbation factor. But they don't recommend you to do that because sometimes it doesn't guarantee that you can find the shortest path. So it's a bit simpler than vSIM and INSAR. For today's homework, I just need you to use vSIM to perform a dynamic assignment. Maybe 2 routes, or maybe three routes, using the simple network. I'm going to upload the simple network, but you can do it and show me some iterations. Show me the iterations, like what you did in the network class. And that's the end of the lecture. Today's lecture is a bit shorter than before. Okay, thank you.